Okay, this is exercise 30 from chapter 25. We've got a circuit here with two batteries, both with internal resistances, and two separate resistors. So for part A, we want to find the current in the circuit, both magnitude and direction. The 16-volt battery, that's going to want to push current counterclockwise, and the 8-volt battery is going to want to push current clockwise. But since the 16-volt one is larger, we can assume that it's going to go counterclockwise. We do the calculation. If we get a positive value, we were right. If we get a negative value, we chose the wrong direction, but we'll still have the right magnitude. So if we start at this 16-volt battery, we're going to go in a counterclockwise loop. We're going to subtract the current times each resistor. So we're going to end up adding up all the resistors, 9, 5, 1.6, and 1.4. That's a total of 17. And our EMF, we've got 16 in that positive direction counterclockwise, minus 8. So 16 minus 8 is going to be our total EMF minus current times our total R, which is 17 ohms, equals 0 because we go in a complete loop. I'm going to solve this for current, and I get 0.47 amps, which is about 470 milliamps. And sure enough, that is counterclockwise. For part B, we want the terminal voltage of the 16-volt battery. So that's the EMF of the battery minus current times the internal resistance. So now that we know our current, we can put that in as 0.47. The internal resistance for that battery is 1.6 ohms, which gives us a terminal voltage of 15.2 volts. So again, slightly lower than the actual 16, that's the EMF. And for part C, the potential difference VAC of point A with respect to point C. So point A is up here in the upper left, and point C is down here in the lower right. So traveling from A to C, counterclockwise with the current, we're following the current, and current flows from high to low potential. So we expect point A to be at a higher potential than point C. And remember, by convention, we say V sub AC. That means the potential A minus the potential at C. So we expect this to be a positive value. We don't know what the values are at those particular locations, but we can just start at A. And we're going to have a voltage drop as we go through the 5 ohm resistor, another voltage drop as we go through the 1.4 ohm internal resistance, and then a loss of 8 volts passing backward through that battery. So drop for the 5 ohm, so 5I minus 1.4I minus 8, and that will put us at VC. So if we rearrange this into this form, VA minus VC, we'd have to move all of these terms to the other side. They would all become positive. That would be 8 plus 6.4 times 0.47 amps, which gives us a positive 11 volts.